My name is Julie Placet. I'm with the order desk of the North American customers at SELTECH. It's nice to see so many of you joining the CES SELTECH virtual event. It's time to start our webinar. What is the plan for this afternoon, Julio?
Hi Julie. Hi everyone. This afternoon we will have our partners and friends from Knowles. Audio and voice now play a central in how we communicate with each other, entertain ourselves or engage with gadgets around the house. Microphones are critical to enabling these experiences. During this webinar, Saket Thukral of Knowles will share more of the latest products from Knowles that are helping customers deliver delightful experience to end customers. We will leave now Paris to join the windy city of Chicago, where Knowles is based. So take a nice cup of coffee, relax, not too much, and enjoy this webinar and stay safe. Hi Saket, thanks for taking the time to share your knowledge with us. The platform is yours. Bye.
All right, so good afternoon, everyone. My name is Saket Thukral. I'm with Knowles Electronics here based in Chicago, our headquarters. My role is that of a Senior Director of Product Line Management and Tech Marketing. Just a quick word on, or a couple words on my background. So I have been in the industry now for about 20 years, a decade or so with Texas Instruments, followed by about half a decade with Qualcomm. And now for the past several years, I've been with Knowles Electronics here. The benefit that I see for myself, having come from TI and Qualcomm and now at Knowles, is that I am now able to piece together the component world that I'm in with Knowles Electronics to the systems world that we have been, or I have been with Qualcomm and Texas Instruments in the past. And what I can say is that the humble microphone that we are going to talk about today plays a mighty role in enabling experiences that seem almost taken for granted in some sense in the big scheme of things. And I'll try and give everybody on the call today a view of what goes on into building the right microphones to address the right use cases and such. So with that, I'm going to get started with the presentation. Towards the end, we can also do a little bit of Q&A if you like. So before I get too deep into the microphones, I just want to talk about a little bit about Knowles, who we are, what we do, and what's our position in the industry. So Knowles is the #1 supplier of microphones in the industry. Knowles invented this technology several years ago, about 20 years ago, and ever since has been the #1 supplier of the MEMS microphones in the industry. And we have held this position through constant investment into the microphone business, continuing to innovate and lead on technology, as well as setting new benchmarks every year or every couple of years in terms of better reliability, better robustness, better quality delivery and such. And a lot of that is thanks to our even longer legacy in the hearing health market, where as well we hold the #1 position in terms of the acoustics supplier in the industry. And that again comes from strong processes and strong investments that we've historically made in that business. With that, recently, I'd say about half a decade or so ago, we invested in digital signal processing capabilities, algorithmic capabilities, and we have now built this whole portfolio of audio capabilities and audio services capabilities that go all the way from component level, which is the things like the MEMS microphones and other transducers, all the way through DSPs and algorithms and systems solution through our sister business units within Knowles. Now, in terms of Knowles as a company, we are a publicly listed company in a very stable financial position, which is something that I think we should mention, given that the industry has seen a lot of churn. The MEMS microphone industry has seen a lot of churn. And through this churn, we have seen many companies come and many companies go, but Knowles is the strong anchor in the industry, and we are here to stay and a reliable partner for customers. Now, in terms of the markets that we serve, pretty much any segment that you may think of that uses a MEMS microphone is something that we address. We have strong ties with the largest customers in pretty much all these key segments of mobile, ear, and IoT. And within these segments, we continue to collaborate with customers in terms of servicing their ongoing needs for future platforms and future capabilities. And I hope to give some insight into some examples of those investments that we make and those capabilities that we bring to the market in the coming slides. Again, just to illustrate again one more time the strong history that Knowles has had in the industry. So Knowles, through its various forms, has been in the market since 1946, starting with the founding of the company by Mr. Hugh Knowles. The initial few years was the focus was mainly on hearing aids and hearing health industry through miniature transducers. And through the years, Knowles has continued to evolve itself into newer and newer capabilities, with MEMS microphones being introduced, like I mentioned, 2 decades ago, to recently the DSPs and the systems capabilities, and as well as certain other capabilities in building high precision capacitors, filters, and such to kind of leverage and build upon our strong manufacturing DNA. So a couple points I'd mention here. As you can see, around 2002 is when the first MEMS microphone was launched. Since then, Knowles has been shipping these in high volume. We hit the milestone of 10 billion MEMS microphones shipped in 2017, and we hope to hit the 20 million mark within the next 12 to 18 months window. So now jumping more into the specifics of our industry and our ecosystem, I'll touch upon some key trends that we are living and breathing. Again, none of this should be a surprise to anyone on the call here, but just for completeness, let me talk about what we saw in the last 12 to 18 months in the industry. A lot of this has been there's been the COVID catalyst that has affected some of the use cases, and they are becoming more central to our daily experiences. Starting from the top left, this is a trend I think pretty much all are familiar with. This is the trend of video logging. This is the trend of content creation. Especially the millennials and the younger generation is deeply into it. People are now building careers by blogging and vlogging on YouTube and other platforms. And this effectively has turned into a strong tailwind for a company like Knowles when customers are demanding better audio capabilities on their consumer devices like mobile phones to be able to create this content with high quality, with non-professional equipment. And this effectively turns into more microphones on devices like phones, going from 1 microphone to 2 microphones, and now from 2 microphones to 3 to 4 microphones per device, as well as demanding higher and higher capability microphones for low noise content creation. Similar to that, to the right, top right, you can see the illustration of work from home, conferencing from home. This again, like I mentioned, is something that got a lot of attention in the last 12 months or so with the COVID situation. And again, it's something which is putting a lot of attention into the notebook market or the compute space, asking the industry, the consumers asking the industry to offer them better capabilities so they can have the seamless experience of being on calls with 360-degree voice pickup, high quality voice pickup, as well as I'll talk about later, the form factors of these devices are now going more towards the bezel-less phone type form factors, the thin bezel or no bezel form factor, requiring the microphones to be integrated in a completely new industrial design concept. Bottom left, we're talking about the ear market. Again, Airpods set the trend in 2016 when they launched one of their newer concepts that took off. And since then, not just Apple, but many customers in the world are in this market, getting into this market and addressing the convenience and the desires of the consumers to offer them seamless communication capabilities and seamless music consumption capabilities through these highly compact and portable TWS type devices. And these devices continue to innovate as well by adding newer features like noise cancellation or noise suppression capabilities, or even adding some of these transparency mode capabilities, which allow you to seamlessly transition between an immersive experience with the TWS headset and switching to the awareness mode, where you'd like to observe what's happening around you in terms of talking to someone or listening to announcements and such. So we'll talk more about that again from a microphone standpoint, what it means and what do we have to offer. And finally, the automotive industry is going through its own churn in a positive way, with electric cars and such getting a lot of attention. But also behind the scene, what's happening is a lot of electronics being added to the car, not just for drive capability, but also for communications and convenience and such, including now even the medium grade brands and medium grade cars integrating capabilities like noise cancellation in the cabin, and consuming more microphones and integrating more microphones for that kind of capability. Now, communication through voice calls or E911 or E112 in Europe continues to be strong, and again, this industry is seeing more churn, more activity around the microphones through the AEC Q103 initiative, which is the automotive equivalent of automotive grade qualification. And again, I'll talk a little bit about it in the coming slides. Okay, so from the use cases, let's dive a little bit into the microphones themselves. And just for reference, I thought it'll be interesting to illustrate what a typical microphone looks like if you were to take the top off. So very simply put, a microphone is a Asic and a MEMS integrated on a PCB and protected using a can on top. Now, simply put, the MEMS device is a capacitor with one fixed plate for Knowles and one moving plate. And if you have the EE background, you would understand that as the moving plate moves through the sound pressure, it creates an electrical signal, which is then picked up by the Asic, and that translates into the audio signal that the codecs and the DSPs then pick up from the microphone for further processing. So this humble microphone looks simple, but it has a lot of complexity behind it in terms of its design, integration, and such. And we'll talk about it in a bit. But one thing I'd like to mention here is, from a Knowles standpoint, we do have this capability of being able to design all these components of the MEMS, the ASICs, the PCB, the housing, and such in-house, which is a huge advantage for Knowles as well as for its customers, because unlike several of our competitors, we don't need to rely on third parties to be able to deliver these technologies for meeting the customer requirements or meeting the application needs. And we are able to move fast and address these requirements as they come along. Okay, so when it comes to designing the microphones itself, when I joined Knowles several years ago, or I was considering joining Knowles several years ago, uh, I was asking myself the question on how complicated can a microphone be, and why do we need these new microphones every so often? Isn't the technology already done and over with in terms of this being a component which is now several decades old into making? And I was pleasantly surprised as I dug into it to realize that we are in a heated battle of innovating around the microphone and continuing to innovate around the microphone, where the customers are pushing us, the competitors are active, and this microphone is nowhere close to being done. And a lot of that comes from the fact that while from the outside it might seem like a microphone's picking up the audio signal and converting it into an electrical signal, once you peel that top layer, you realize that it's a complex balance of multiple KPIs, multiple performance indicators, and the ideal microphone does not exist. What does exist is microphones that are ideal for certain applications at a certain cost point and such. So that's what is the complexity in designing the microphones and continuing to innovate around the microphones, is to balance these various KPIs and finding the right balance for the right application and being able to deliver that at a cost point that is competitive in the market. So just for reference, I captured certain definitions on the right. We'll talk about some of these as I talk about the microphones in the coming slides. But just for reference, I'd say the key ones to remember are SNR, which is the signal to noise ratio. In very fundamental sense, that's the ability of a microphone to pick up soft sounds with minimal noise. And THD or AOP that we will talk about in the coming slides is the capability of the microphone on picking large sound signals with minimal distortion. So better the THD number or better the AOP number is, it directly translates into the microphone's ability to pick up loud sounds without distorting itself. One other key term that we will talk about in context of certain microphones is the LFRO. This is the low frequency point. In some sense, it defines the lower end in the bandwidth, lower limit of the bandwidth for the microphone. So in some sense, how low in frequency can a microphone go with a near flat frequency response? So these three parameters are sometimes considered the most critical parameters for many applications, because this in some sense bounds the performance profile of the microphone and is one of the or some of the most important parameters to pick when thinking and deciding of certain applications. And the reason why these are important are different. So, for example, the SNR or the low sound pickup capability without noise, that capability is super important when we are thinking about these use cases like content creation, clear communication in an office setting, when beamforming type applications are involved or algorithms are involved. Or I talked about the transparency mode in the previous slide. That's also called the pass-through mode, when you're trying to pass the outside sounds through the microphones, through the earphones into the ear, and you don't want to perceive any hiss or pass any hiss, which is also the electronic noise of a microphone. And this in effect means that better the SNR of the microphone, the lower the noise of the noise floor of the microphone, the better it is capable to handle these situations where you want to have high fidelity sound pickup without adding a lot of noise into the system. Now, I have a couple of microphones that we typically recommend to customers that are outstanding microphones for these applications. Two microphones, Everest and Cornell 2, are our recommended microphones in the digital domain. And one of the recent microphones that we have launched is called Lazarus. It's a very high performance analog microphone. As you can see, 68.5 dB SNR. And another one with that, which is very popular, is a mid-end Tochi platform. So these four microphones, two analog, two digital, medium end and high end, are our recommended microphones when customers want to look at core performance of SNR for these applications. Now, I have some audio files with recordings to illustrate the difference between a low SNR microphone and a high SNR microphone, and what the sound is perceived as. Webinar is not a good forum to play those sounds, so if you're interested in getting these audio samples to listen for yourself, please reach out to your SELTECH contact point, and we'll find a way to get these audio files over to you. Similar to SNR, we have the, like I mentioned earlier, the THD or the AOP vector that we designed for. This is really designed for the upper end of the spectrum of sound in terms of the sound levels. Really, why we need to care for these are recordings in loud environments, recordings in presence of wind noise, or recordings when the microphone and the speaker are placed in close proximity. In these environments, there is a risk that the microphone may get saturated if it doesn't have enough capability to pick up, loud sounds. This is why it's important to carefully pick the microphones if one of these is your application. Loud sound recordings, recordings in the presence of wind noise. For example, if you're designing a microphone for an earbud, it's important to pick up microphone with large AOP for meeting those requirements. Again, on the right, I show some illustrations with spectrogram. So there is the microphone with large AOP capability on the left, and another microphone with a lower AOP capability on the right, both recording the same piano recital. And you can see on the left that the pickup in the spectrogram is fairly clean. There are no distorted signals in the top half of the curve, while the microphone on the right illustrates a lot of these harmonics on the top, which is an illustration of the distortion being picked up by the microphone. And in terms of the recommended microphones for these applications, again, unsurprisingly, these fall to the same types of microphones where we push the SNR higher, just because these are designed to have the largest dynamic range. And this is where we make the maximum capability available to customers when they're looking for the microphones with the best range on the low end for soft sound pickup, as well as microphones on the high end for the loud noise pickups. So again, these same four microphones are good stand-in for the AOP capability as well, or the high AOP capability as well. Finally, we have a large portfolio of microphones that we designed for targeted applications. And here I am talking about 4 sample applications or needs in the market to illustrate the point. So on the left, we have the microphones that work really well for ANC applications. ANC applications typically prefer microphones with low LFRO, which means that they like flat frequency response in the very low frequency band as well, to push for the maximum cancellation in the low band. And Ellen and Winfrey are two microphones with that type of capability, in addition with large SNR and AOP to really make these well-rounded microphones for ANC application. The middle one is the second one is talking about the trends that I talked about in the notebook market, where we are integrating more and more microphones in the screen, and the screen is turning more and more towards a thin bezel design or a no bezel design. So bezel, which is the outer boundary of the screen, is disappearing if you look at the trends of the latest notebooks. Again, to offer maximum surface area, maximum viewing surface area to the consumers. And what happens when the bezels disappear is that the microphone, which is typically integrated at the top edge of these screens, together with the camera device, they need to start to become thinner and thinner to be able to enable those thin bezels. And we have introduced these microphones, Baracus 2 and Marina, with their wide dimension of 2 millimeters, primarily for that application, to allow our customers to integrate these thin microphones into the bezel to achieve those thin or bezel-free designs. The other innovation that we are working on is in the automotive space. Here we are looking to introduce two microphones, one analog, one digital. The Tron microphone is the analog version, and Volt microphone is the digital version. I mentioned earlier the AEC-Q 103 qualification spec. This is a qualification spec defined by the automotive industry to qualify microphones to the automotive requirements, and we are working towards qualifying both Tron and Volt against that AEC-Q 103 spec. In addition to that, the other need this industry has is long-term supply warranties or supply guarantees. Traditionally, we haven't done that. Nobody in the industry has done that in the microphone world for the automotive customers. And though Knowles microphones tend to stay in the market for 5 to 7 years, nonetheless, we still thought it's important to work with our customers and offer them this 5-year supply warranty, which puts them at ease when they're designing this microphone in, or these microphones in. And finally, we also recognize the need in the market for low-cost platforms. Now, not every application requires the best and the most advanced microphone. There are many applications that are cost-sensitive, and for those cost-sensitive applications, we are offering several analog and digital offerings, like Morello Luisa for digital and Quartz and 4.2 for the analog world, which are let's say a lower end of our capability spectrum, but at the same time they are high quality, high reliability microphones from Knowles that are designed for those applications where the customers don't need to push the performance to the max. Okay. My final slide on the microphones itself is about the fundamental architecture of the Knowles microphone and how does it relate to some of the competitive designs. So this is the illustration of the MEMS design. I talked about the MEMS being like a capacitor with one fixed plate, which is at the top. We also call it the back plate. And the moving diaphragm at the bottom, which is also called as the moving plate of the MEMS design. Now, microphones are unique in the sense in the sensor world that they are exposed to the outer elements. Other sensors like accelerometers and gyroscopes are all hermetically sealed. They don't have any exposure to the outside elements. and from that perspective, they are typically very robust. Microphones, on the other hand, are exposed to the outer elements because you need to leave a port opening for the microphones to pick up the sound waves. And when that happens, you're also exposing the microphones to elements like dust and particles, which can ingress and have a negative impact on the performance of the microphone. So this slide illustrates, or these illustrations are there to show how the Knowles architecture of the MEMS with one solid or nearly solid diaphragm at the bottom is designed to protect against those particle ingresses. So in some sense, the probability of the particle ingressing and getting in between the backplate and the diaphragm with this architecture is minimal. And when that happens, you can be rest assured that in your production lines or when these devices reach the field, the probability of returns is far lower than the architecture on the right, which has a sieve-like architecture for the backplate at the bottom of the microphone as well. Which allows for these particles to get in and get stuck between the backplate and the diaphragm, causing field returns or field failures, or factory returns and factory failures. Okay, so with that, I'm going to close my talk and open it up for questions. Just by saying that with Knowles, what customers get are these four fundamental values. We have the scale of supply, which means that customers, when they work with us with the right forecasts, we have no issues supplying their requirements. We help several customers do very fast, high volume ramps, and we are available to offer that capability to all our broad customers as well. Technology, I mentioned how we design our own microphones start to finish, which means that we work with customers to address their evolving needs, as well as we have a good front row view of what's happening in the industry to start to plan for a roadmap to address these future needs. Our support and quality are benchmark. We have worldwide support with excellent field application engineers, as well as a very active sales team to offer frontline support to customers. And finally, the Knowles brand is known for its high quality and consistency in microphones for many years, and we continue to build on that. Okay, so with that, Savannah, I'll hand it off to you. Okay, so there's a question, says, what is the best Knowles MEMS for wind noise cancellation? Okay, so let me go back. So wind noise cancellation is really a function of finding the right balance of LFRO and the AOP. So wind noise, if you look at the frequency profile of the noise itself, it's primarily dominated in the low frequency band. So I'd say something like a 20 to 25 hertz is where most of the wind noise energy is at. So the best microphone that you can pick up for preventing wind noise type saturation would be a microphone with LFRO, which is slightly higher than that. So let's say something in the mid 30s, and a microphone which has a good 1% THD profile and a good AOP profile. So if that's the right assessment from your algorithms team as well, then I would say then that the microphone Tochi, the analog microphone that I have on the screen here, is one very good example of that. It also has the benefit of small size. So if the use case is an earphone, which is likely to be affected by wind noise, then the combination of small size, 35 hertz like LFRO and high AOP and 1% THD point mean that that's the best or one of the best microphones that you can pick up for wind noise mitigation. Okay, give me a second. I see there are other questions. I'm trying to get to those. Okay, so there's another question about pass-through with no hiss. Okay, so pass-through no hiss is about enabling the sound pickup from outside world. So this is something where if you have over-the-ear headphones with ANC capability, so they will seal your ears in and in some sense prevent the outside sound from getting in to get the best noise cancellation technique. Now, for these applications, like for over-the-ear noise canceling headphones, as well as for those closed-fit TWS devices which seal your ear canal to prevent outside noise or outside sounds from coming in these devices, you sometimes would find capabilities where the manufacturers will offer the ability to have the outside sound being passed into the ear canal through the headphones or the earphones. Now, you don't want these to be physical in nature, so you don't want to remove these headphones or earphones. So what you do is pick up the outside sound through the microphone and then play it back into the ear canal using the dynamic or the balanced armature that you may have into the device. So now, since you're picking up the outside sound through the microphone, any noise that the microphone or the self noise of the microphone gets coupled and played back into the human ear. And the human ear is sensitive to some of this noise in certain frequency bands. So what we typically would like to do when we're designing for this application is to have a low noise profile overall, but also specifically in these certain frequency bands where the human ear is very sensitive to sounds. And that would lead to a good experience with low noise. And the Lazarus microphone here is one such example of a microphone that's designed to have that very low noise profile for this type of application. Okay. Okay. Give me a second. Okay. Savannah, if you can hear me, I'm struggling to see some questions. They're not coming out very cleanly on my screen, but I'll keep talking about it. But if you don't mind sending some of those to me via WhatsApp, I can then come around to those. So another question I see online is, what are the temperature maximum for Knowles Automotive MEMS mics? Going back to that, you can see here the analog version is -40 degrees C to 85 degrees C. Oops. And the digital version is being designed for -40 degrees C to 100 degrees C. Okay, another question is, beamforming where two microphones could be handled with microcontroller for an IoT. Yes, that is something that can be done. Typically, you would need a microcontroller that's designed for audio processing to have enough of the horsepower as well as the memory to be able to handle that. And as an example, the Chelsea DSP from Knowles is one such DSP that can handle this type of beamforming application. Okay, give me a second. Okay, there's another question on, can you advise us and help us build prototypes? So yes, when it comes to component selection, as well as guiding a little bit on the industry, the mechanical design, the porting, the gasketing and things like that, Knowles does offer customers some advice. The level of advice would really depend upon the needs as well as the capabilities that we have. But feel free to reach out to us through your Knowles contact, and we will do the best to support you in your needs. Do you offer evaluation boards with mics? Yes, we do. And these boards are called the Muskie boards. Typically, we have these available through some of our online distributors. But again, please reach out to your Knowles contact, and we can offer you microphone evaluation boards. Okay, there's a question on what is LFRO and what is the benefit. LFRO is the -3 dB sensitivity point on the low frequency band. So think of it as the microphone definition or typical microphone KPIs have a reference point to 1 kilohertz. Typically, the sensitivity of the microphone at 1 kilohertz is referenced as the microphone sensitivity. And then if you think about the frequency response of the microphone, it typically has a low frequency start point and a high frequency resonant peak. And between the -3 dB point and the +3 dB point, reference to 1 kilohertz frequency in terms of the sensitivity is the typically accepted frequency bandwidth of the microphone. So the -3 dB point, which is typically on the low frequency side, is the point called the low frequency roll-off. And the benefit, it's not a benefit in itself. Now, depending upon the application, the algorithm developers will typically have a preferred LFRO point. So applications like beamforming and ANC tend to desire a low frequency roll-off point, which is very low, giving them more of the flat curve or flat frequency response in the low frequency band for cancellation or other applications, while other applications like communication mic may not have a strong desire on a specific LFRO to the point where they may even desire a high LFRO like 80 hertz or so, because the application is only human voice pickup, and they don't want to be dealing with saturations that may happen in the low frequency band if the microphone is sensitive to the low frequencies. So that's the context of LFRO. Okay, let me see if there are other questions. Okay, I don't know if there are any other questions. Hold on. Okay, there's a question of what is the LFRO for LN and for Winfrey mics. So here, the LN microphone has a 15 hertz LFRO and the Winfrey mic has a 13 hertz LFRO. Okay. Okay, so there's a question on why a customer will use a differential mic instead of a single-ended mic. Yeah, that's a very good question. So the pros and cons of single-ended versus differential mics are as follows. Single-ended mics are a single output from the microphone level reference to the ground. So in some sense, they are easier to design with when it comes to routing. So you're only routing one signal. The differential microphone and the other thing they have a benefit on is they only consume a single channel of the ADC in the codec. Now, the downside of a single-ended microphone is that they are more susceptible to noise. So let's say you're routing the single channel from the microphone to the ADC, and close to the routing, you have another signal that's being routed, which is noisy. So what happens then is that if you introduce noise between the microphone and the codec, there is almost nothing that can be done about it in terms of cleaning that noise out. So single-ended designs are sensitive to noise pickup, while the differential signals or differential microphones are microphones that are floating in some sense, as in they have no reference to the ground. They really have a reference to themselves between the two lines, the positive and the negative outputs, output P, output N, and these dual lines are now more immune to noise, because any noise that is picked up is cancelled between the out P and the out N. So when you have applications which are very noise sensitive, like I would say the environments which are very noisy, like a mobile phone platform, for example, is very noisy. There are lots of components in there, lots of twiggling of signals happening. So in those environments, it's typically better to consider a differential signal rather than a single-ended signal. But it's really a function of the design of the platform and what are the noise sources and can they be controlled or not. And then you pick between single-ended and differential. Okay, there's a question of, do you see an end of the top port microphones as they have lower performance overall? So that's again a very good question. So we have seen a continuous decline in the demand of the top port microphones primarily for that reason, which is you can build cheaper and better bottom port microphones but compared to a top port microphone based on just how the research or just how the physics of the microphone works, excuse me. What we are seeing now is more and more the customers prefer to use bottom port mics for that reason. But then there are some very specific industrial design requirements where the top port microphone is still a need and popular. The best example is the computing space, where the microphone is typically placed on the camera module at the top of the screen. And in this configuration, you want the camera and the porthole of the microphone facing the user. And the only way you can do that without adding a lot of physical size requirements in that space is by integrating a top port microphone. So the port of the microphone and the camera then face the user, and the top port microphone tends to be a better fit in that application. But for most practical applications, we are now seeing consumers work around the physical constraints and start to use more and more the bottom port microphones. Okay. Okay. Do you design your own ASIC? Do you design the ASIC on your own or use ODM? So we design the ASICs and the MEMS in-house. We have R&D centers in the US, in Denmark, and in India. And this is where both our ASIC and our, as well as Switzerland, I should add, And these are the locations where our design teams are at, and all of our ASIC and MEMS are designed in-house. Okay, there's another question. Why analog mics seem better than digital? Actually, that's not the case. Um, the best way to think about this is there are trade-offs between analog and digital microphones. So analog microphones are easier to design, as in the microphone itself is easier to design because there's less content in the microphone itself. But they are slightly more difficult to design with at the system level, because now you need to match the analog signal from the microphone to the analog capabilities of the codec, setting the right DC levels and gains and such. And like I mentioned earlier, the analog signals are more susceptible to noise pickup as you're routing them from the microphone to the codecs and such. Digital microphones, on the other hand, are more complex to design. The microphone itself is more complex to design. You integrate the ADC and signal management and so on within the microphone. The benefit, though, on the other hand, is that once it's digitally converted, the interface to the codec and working with the microphone then becomes significantly easier. Now, sometimes what you would see is two microphones with an equivalent motor and an equivalent ASIC. The analog will seem to have a slightly better SNR compared to the digital microphone, and that is really a function of that the digital microphone has more signal processing happening, like the ADC, which is not yet the case for the analog microphone. But at the system level, the digital microphone tend to perform better and are able to deliver better performance overall than the analog microphone. Yeah, so S and A on these charts are SNR and AOP. I should have mentioned that. Okay, so there's a question on whether a mesh will be better to dampen the noise profile. So typically speaking, the mesh is a good way of dampening the high frequency component of the signal, but not so much the low frequency component of the signal. And the saturation has to be watched out for, the microphone saturation has to be watched out for in both the low band as well as the high band, or rather I should say that the full band of the microphone. So mesh can help with the high frequency bands, but not so much with the low frequency band. So all in all, if the microphone is going to be placed close to the speaker, and there is a risk of saturation, and the speaker could be playing any components of the frequency, the best mitigation against that is to pick a microphone with low distortion profile and high AOP. And examples here again are likes of Cornell 2, Lazarus Tochi. These are some very good microphones with high AOP and low THD profile to very high dBSPL levels. Okay, so I see one question already there from John Kapler. Sound pressure level above 85 dBSPL is usually harmful for human ear. 130 dBSPL is like noise of a gunshot. What real life application could be where one needs this high AOP of 130 dBSPL? Isn't the human ear saturated before it goes to the microphone? Okay, very good question. And the way to think about this is instantaneous sound versus sustained sound. So your point is very valid that at these sound pressure levels of 115 and above, the human ear would start to get impacted and would probably lead to bad outcomes if you were to stay in those sound pressure levels for a long time. Club houses, for example, or clubs, if you were to take a sound pressure level meter, you would see that the sustained sound pressure level can be as high as 115 to 100 dB SPL, depending upon where you are vis-a-vis the loudspeakers in that setting. From a microphone perspective, why we recommend these high dB SPL microphones is to tackle the instantaneous sound pressure levels. Example being, if you're at a piano recital and you are let's say a meter away from the piano, what you would see is the instantaneous elements in certain frequency regions will breach this 125 to 128 dB SPL levels. And this is where having this microphone with enough headroom allows you to capture the sound with maximum fidelity. Okay, moving on to the next question. Are the Ellen and Winfrey microphones shown for ANC new and recommended by Knowles for ANC headsets? What would be the recommended digital equivalent? Okay, so yes, Ellen and Winfrey are available for design. On the digital side, the most common ones that are used by customers are the Cornell 2 microphone. And there's another one that I didn't talk about here, which is the Cameron microphone. I'm going to put the names in the chat. I don't know if you'll be able to see or not. But Cameron, C-A-M-E-R-O-N, and Cornell 2. These are our two recommended digital microphones for the ANC application. What provides the voltage to charge the capacitor mic? Is it external or is it an electric element? Okay, so in a MEMS microphone, you supply a microphone voltage. Let's say it's a 1.8 volt supply to the microphone, and internal to the microphone, what we have is a component called charge pump. So this is the component that biases the MEMS and is responsible for keeping the capacitor at a constant charge level by continuing to replenish the charge level in the capacitive plates of the microphone. So if you remember, or if you know the formula, Q is equal to CV, charge is equal to capacitance times voltage, and if you hold Q constant, the charge constant using the charge pump, any change to the capacitance value will translate into a change in the voltage across the capacitor, which is what is then read by the Asic and translated into the audio signal. So to answer it in summary, there is a specific component that's designed in the Asic. We call it the charge pump, which then leads to the biasing of the capacitive plates. Okay, do you have plans to further develop your ultrasonic capable sensors like the 641LU? Sensitivity at lower signals would be of interest. So yes, so off late, more and more of our microphones have a much larger response curve in the ultrasonic band. Example, Cornell 2, our resonant peak in Cornell 2 has moved from about 24 kilohertz in Cornell to about 36 kilohertz, or actually 46 kilohertz in Cornell 2. So more and more of our microphones have wider and wider bandwidth. The newer generation definitely so. And I would encourage you to, again, reach out to us offline through your support channel, SELTECH contact or Knowles contact, and we can have a conversation around the specific needs and what would be a good follow on to the SPH641LU if you're looking for something new. What is the typical noise floor of ANC software system? Is there a point where mic SNR is not useful anymore? This is a very controversial question, and I don't want to get into trouble with any of my customers by sharing my opinion on this. But what I would say is the human ear or the experience of the human ear is a very personal thing. What may sound like absolutely fine to me may sound noisy to someone with a golden ear. So what I would say today is from a ANC perspective, the noise floor that is generally considered to be good enough for a majority of consumers that leads to about 25 to 30 dB suppression. For that kind of suppression, the microphone that most people would consider good enough is somewhere in the 65 to 68 dB SNR, and rest will depend on the details of the system design. Then there are customers who are looking for 70 dB or thereabouts for the most premium solution ever, and I wouldn't say that they are over pushing it. I think it's a function of the trade-offs and what tier of ANC are customers targeting, or what tier of customers are they targeting in terms of premium, mainline, or a marketing checkbox. So I would say that so far we haven't reached a point where there's no benefit in pushing the SNR anymore. But what I would say is that once you get into that 68 dB or thereabouts, we are definitely approaching, in my opinion, definitely approaching a point of diminishing returns. Okay, next question is there any microphone available or future plan which is also robust to dust and water like IP57, IP68? So on the dust front, I already mentioned that the microphones that Knowles built are inherently quite robust to dust, though they are not meant to be the IP5X class. At the same time, what I would say is inherently integrating protection within the microphone to head towards a IP57 or IP68 class is something that we continue to look at, pay attention to, and it's something that we are not ready to publicly talk about at this stage. Are top ports or bottom ports more popular, bottom ports being better performance? Yes. So another good question. So in the last decade or so, there's been a definite shift from top port microphones towards bottom port microphones, primarily because of the way the microphone physics works. So if you're familiar with the MEMS microphone design, then there are two vectors that we optimize or try to optimize for. So any air volume that is from the port of the microphone to the MEMS is called the front volume of the microphone, and any air volume that's behind the MEMS element and between the MEMS element and the can is the back volume of the microphone. So for a good microphone performance, we want to limit the front volume and make it as small as possible, and we want to maximize the back volume as far as possible. And just the way the microphones are constructed, it's very difficult to achieve that with top port microphones, or it gets super expensive. This is the reason why the industry shifted from primarily top port microphones to primarily bottom port microphones now, and we continue to see that trend more and more, in the sense that more and more customers are shifting from top port to bottom port design strategies. Now, there are a few exceptions to that. The most common exception is the notebook space, where if you again think about the industrial design of a notebook with the camera and a microphone or a pair of microphones to pair with that camera at the top of the screen, then think of how that would be constructed with a PCB hosting the camera module and the microphones. You want both the camera and the microphones to be pointed towards the user. Now, if you use a bottom port microphone, then you'll have to place the microphone and the camera on opposite sides of the PCB, making the construction thicker and expensive and difficult to integrate. So that is one most common area, the notebook space, where we see that the top port microphones continue to be very, very popular. I'm sure there are probably a few other cases like that in terms of where the industrial design of the end device requires a top port mic, but that's few and far between now beyond the notebook space. Is there any plan to incorporate ALC capability directly in MEMS Asic rather than requiring external circuitry to perform this function? I assume ALC is automatic level control, Brian. If that's not true, please let me know, or even if it's true, let me know. I am not too clear on exactly what you mean by ALC to be able to comment on that. I'll move on to the next one and come back to you. Okay, so you say yes, automatic level control. The automatic level control is not something that we are actively looking at this point, because the level of control needed would be very much dependent upon the application in some sense. So the assumption here is that this is something that could be easily tackled in the DSP, and in terms of finding the right partition between the microphone and the rest of the system, this one seems more in the domain of the larger system that has more context available to it. Now, having said that, we do have the smart mic capability, if you're aware, where we have the DSP and the microphone integrated together. That's an area where such a function could be implemented. But at this point in time, this is not something that we believe is ready to be integrated into the ASIC of the bare microphone itself. When audio engineers are asked the question, who makes the most popular microphones in the world, they should say Knowles versus other studio mic makers. I don't know if there's a question to that, but yes, thank you, Joe. I think that's what our assumption and hope is, that we are considered the premier supplier of the Knowles microphone, of the MEMS microphone in the world. Any plans to increase even more the microphone AOP? So this is something that comes up in context of speaker protection from time to time. In the past, we have talked to customers about this capability, but we couldn't find a good enough business case, so to speak. There wasn't much interest. So Clement, if you would like to have this conversation further in more detail, so we can understand your thoughts and needs, yes, we would be happy to entertain such a discussion. Any consideration for mounting MEMS onto Flex PCB? More advanced topic, I would say, and again, very, very specific to a certain application. We haven't yet come across a high volume opportunity, a high volume application where the added cost and effort of mounting this onto a Flex versus a PCB would be a worthwhile exercise. Again, this is my opinion today, and I'm sharing very, very straightforward opinions here. So again, interesting thought, something that comes up from time to time in our internal discussions, but we haven't yet found the right commercial reasons to do it. Which new features for MEMS mics will come up in the next years? Which trends do you see? Okay, very interesting question, Teresa. Thanks for asking. So there are a few elements in the MEMS microphone world that are being pushed and challenged. The first one I would say is the dynamic range. So dynamic range meaning the combination of SNR and AOP put together. There was a question earlier on whether the ANC application has reached the point of diminishing returns as far as the SNR goes. What I would say is that there are other applications where customers are looking for higher and higher SNR and AOP. So that's an element that we continue to push forward. Excuse me. The other element that we are seeing where customers are coming up with newer requirements and tighter and more aggressive requirements are the power consumption and the robustness of the microphone itself. Now, power consumption more in context of wearable devices like earphones and such, dealing with small batteries, where every element of the system is being looked at and being driven towards becoming more efficient to drive more and more battery life out of these devices. So that's something that we are looking at. Even longer term, I think the edge processing is likely to get more attention, and we are likely to see newer architectures with more intelligence again integrated fundamentally into the microphone. But this is again looking at something which is even further out at this point. There's a question on which microphones have DSP incorporated. I would suggest looking at Smart Mic or searching for Smart Mic with Knowles, or talking to your Knowles contact representative for more details on that. Are MEMS microphones used in directional mics, example hearing aids? Yes, MEMS microphones are being used in areas where directionality is needed, including hearing aids. We have a sister organization within Knowles that specializes in MEMS microphones for hearing aids. And then even in consumer world, whenever you have more than one microphones that you see on a device, like a smart speaker integrating 4 to 6 microphones, or an earphone having 2 microphones, one at the top, one at the bottom. These multiple microphones or multiple omnidirectional microphones can be used to put together a directionality context in the software. That's how beamforming works. Okay, so we are coming at the top of the hour and the questions keep on rolling, so I'll try and run through the last couple of them quickly. And then if your answer or if your question wasn't answered, please feel free to reach out and we'd be happy to address other questions as well. How is the quarter frequency of the microphone controlled? Is there any trend in this? Sorry, where did it go? Apologize. Okay, and is there any trend in this for headset and smartphone? So yeah, there are several ways we control that. It's a combination of several design elements, including the MEMS design, the package design, Asic design, and such. And generally speaking, more and more customers are looking for the widest possible bandwidth. So low LFRO to ultrasonic peaks. These are the two elements to control to have the largest bandwidth. And Cornell 2 is a good example of such a microphone with that wide range of or LN for that matter is another one where we have ultra low LFRO and very high resonant peak. Some competitors offer Wacom sound microphones similar to Knowles' first smart mic. Is this useful for applications or is it too simple? So again, this is one of the more controversial ones. We believe that having an integrated Wacom sound feature in microphones would be of interest to very specific thin set of applications The challenge is that that is too simplistic to have a meaningful power consumption benefit across most applications. So this is something to look at, but I would say very targeted applications could benefit from such an implementation. How much do mechanical vibrations from environment or from other components in the device, example, haptic feedback, impact microphones? Oh, MEMS microphones, very little. That's one of the benefits of MEMS microphones, that they are they have very low sensitivity to vibrations. Okay, which sister organization for mics and hearing aids? It's the Hearing Health Technologies, HHT division. Again, please reach out to your Knowles contact. They can put you in touch. Are your MEMS mics generally omnidirectional pressure transducers? Yes. Or are they pressure gradient transducers such as, no, so we build omnidirectional MEMS microphones only at this point. We have, again, looked at certain other combinations as well, but in the consumer world, we have generally seen the need for omnidirectional microphones. Okay, so with that, I think I covered all the questions that came through on the chat window. If not, if you have further questions, please reach out through your Knowles contact, and I'd be happy to keep this engagement going. And thank you so much for such an engaging discussion. Really appreciate it, and have a good day. Thank you.